Alright, let's try another example of finding the standard deviation by hand. It says the following numbers were obtained by sampling a population: 5, 8, 16, 17, 18, and 20. Find the standard deviation of the sample. First thing I want to note, this is a sample. So what does that mean? That means we're going to divide by n minus 1, or the number of items there are, minus 1. There's 1, 2, 3, 4, 5, 6, I see. So we're going to be dividing by 5 when we divide. Okay, so the first thing we need to do is calculate that mean. And this one I'm using x bar because it is a standard deviation. Don't worry about the notation, but it's the mean. So how do you find the mean? You add them up. 5 plus 8 plus 16 plus 17 plus 18 plus 20. We divide them by the number there are. Again, there were 6 here. So let's see what we get. Go ahead and put that into your calculator. I'm getting a mean value of 14. The mean's not always a nice number. In these cases it is, which makes it a lot easier for us. So we have 5, 8, 16, 17, 18, and 20 as our data values. What we do with those data values after we find the mean is we find the distance from the mean. In other words, we do the data value minus the mean for every single one of these. So 5 minus 14, 8 minus 14, 16 minus 14, 17 minus 14, 18 minus 14, and 20 minus 14. Let's go ahead and see what those equal. Put those into your calculator, see what you get. For the first one, 5 minus 14, I'm getting a negative 9. 8 minus 14, I'll get a negative 6. 16 minus 14 is a positive 2. 17 minus 14, positive 3. 18 minus 14, positive 4. 20 minus 14 is a positive 6. Let's just double check real quick. We should add these together and get 0. So 9 and 6 is 15, so I have negative 15. 2 and 3 is 5. 4 and 6 is 10, 5 and 10 is 15, so I have a negative 15, positive 15. If I add these together, I do get 0, so it does seem like I'm doing this properly so far. Now what do? I take those deviations and I square them. Negative 9 squared is a positive 81. Be careful with your parentheses on this one. You should always get a positive number. Negative 6 squared is 36. 2 squared is 4. 3 squared is 9. 4 squared is 16. And 6 squared is 36. Go ahead and add all those numbers together. When you add all those numbers together, let's see what you get. Do so now. Please double check my math. I was getting a sum of 182. So now that I've added all those standard deviations together, I'm going to do 2 steps at once. What I want to do is divide it by whatever number I need to divide it by. In this case, we determined that it's n minus 1, so I'm dividing it by 5, not 6. It's the sample, so I divide it by n minus 1, and then I take the square root. I'm going to do that all in one fellow swoop in my calculator. I am not going to estimate this at any point in time until the very, very end. And when I do this, I'm getting a standard deviation. Please double check my math. I'm getting a standard deviation of approximately 6.03 if I round to 2 decimal places. Again, I want you to have context. You calculated the standard deviation for this, but what the heck does this actually mean? Well, if you're a visual person like I am, a visual learner, what I like to do is actually see what the heck we're talking about here. So what we're saying is if the mean of this data is 14, what we want to do is add and subtract that mean from both of those. That standard deviation. So if I added 6.03, I would have 20.03. And if I subtracted 6.03, I would have 7.97. So what we're saying is the majority of these data values, remember this is just a sample, we're not seeing the entire population. The majority, over 80% of these data values are between the values of 7.97 and 20.03. We don't have any context, so we don't know what this stands for, what these numbers stand for. Maybe that's in terms of millions of dollars or something like that. Okay, you could add context, or we could find real-world problems to add context to this, but that's what a standard deviation is. It's just a distance from the mean. Add and subtract that distance from the mean, and we're saying the majority of the data lies between these two numbers, in this case 7.97 and 20.03, presuming the data is distributed normally, which is an assumption we do make this entire chapter. Okay? So the last thing that I want you to do is I want you to double check this on your calculator. Again, it is on page 5 of this book. The next one, you'll see the written directions on how to check this, but just talking through it, I'm working on the TI-30XS. I'm going to hit the data button. I'll hit the data button again and hit enter to clear out my first list. So now I'm looking at the data list L1 with nothing written in it. I'm going to hit 5, enter, 8, enter, 16, enter, 17, enter, 18, enter, and 20, enter. So I have that data list in my L1 data in my calculator. I hit second button, the green button, data again. It says 1 var stats, so I hit enter. I make sure I'm on L1. I make sure I'm on frequency of 1. I hit enter on calc. I scroll down to number 3, which is S of X, and it says 6.033, which is exactly the answer we got. So very quickly we could check standard deviation on our calculator.